viewers, welcome to another session of your MOOCs course, Internet of Things, Design Concepts and Use Cases. Till now, we have studied so many hardware based projects. We have worked upon variety of sensors and interfaced them with Arduino. But now, we are going to work upon a case study which includes multiple sensors, and we will be projecting them together to measure some environmental parameters altogether. You might have gone through the problem statement of this particular case study. You might have studied the different aspects that affect your indoor air quality. So, now we are moving to the hardware as well as software implementation of this particular case study. And as per the discussions that you might have in the previous video with Dr. Matri Datta, we are proceeding ahead with a hardware system over here. And you can see on the screen, these are the hardware units that we will be utilizing for designing this particular system. You can see, first of all, we have your favorite Arduino Uno board. And along with this, you already know DHT11 sensor, which we have already interfaced for measuring temperature and humidity conditions. Along with this, now you will see 4 new parameters, or we can say 4 new hardware units over here. First of all, we have ESP8266 module. This particular module is utilized to connect your system to Wi-Fi setup. It will help you to send your data from the hardware setup to internet, so that you can monitor it from anywhere. It means if you are monitoring your air quality conditions from variety of field areas, like maybe some urban areas, some rural areas, and you want to get real time data from there. In order to do that, you definitely need a Wi-Fi module. And this ESP8266 is one of the best module that you can utilize in combination with your Arduino Uno board. Next to this, we have your CCS811 sensor. This particular sensor can be utilized to measure 2 different environmental parameters. One will be your VOC component and other will be CO2 component. As you know, CO2 represents carbon dioxide and VOC represents your volatile organic compounds, which is basically a mixture of different environmental pollutants. Next to this, we have SDS011 sensor, which we have utilized to measure dust particles. So, this particular sensor can help you measure PM10 as well as PM2.5 particle pollutants. And along with this, we have a multi-gas sensor from Groove, which includes MISC 6814 category, and it can be generally used to measure 8 different gases that you can find in detail with the manufacturer data specifications. But currently in our project, we have utilized this particular sensor to measure only 2 gases, considering the requirement of this particular case study. So, as you can see on the screen right now, the first sensor we have utilized to measure these 2 parameters. Then we have your dust parameter sensor, which measures PM10 and PM2.5. After that, we have a multi-gas sensor that we have utilized to measure CO and NO2. And after this, we have your DHT11 sensor, which we measure for temperature and humidity. Other than this, if you are planning to go ahead with some advanced networks where you need on-chip Wi-Fi board, so for that I can suggest you one thing. There is a combination of Arduino Uno and ESP8266 board, which is widely known as Node MCU. So, if any one of you is interested to work on that chip also, you can find that at a very reasonable price in the market, and you can use that together for sending your data online, which is basically combination of Arduino Uno only and with your ESP module. However, in this particular case study, we are utilizing both these modules separately. Before we move ahead with your sensor system design, it is always necessary to go ahead with the parameters or the ranges as well as the cost of your sensors. So, some quick highlights I have provided in your table here. These details generally you can find from manufacturer data specification. So, before you buy any of your sensor, we always recommend that you should go online and check data sheet from the respective manufacturer. For example, if you are buying your sensor from Sparkfun company, then you have to check manufacturer specification sheet from the same manufacturer, so that you can get relevant information about your sensor, which includes the operating range, the measurement range, along with that the type of working principle or the methodology followed by the sensor. This thing will also help you to ensure proper library utilization in your Arduino IDE platform, because most of the time these respective sensors will require libraries from the same manufacturer. Since, as I already told you in previous videos as well, in order to measure even a single type of parameter, you will generally find thousands of different sensors that are designed by different types of manufacturers. But your requirement, your specification range, your operating range may be different, and accordingly you have to shortlist your product from a sea of products available in the market. Once you have finalized your list based on the manufacturer specifications, then you are ready to work upon that with some calibration as well as with some installation procedures. Other than this, while buying your sensors for some real time measurements, it is always recommended that you should go ahead with some calibrated sensors. So, this is essentially useful when there is some research project involved. You always have to consider a sensor which is either calibrated by the manufacturer itself, or they provide you proper calibration guidelines that you can utilize at your place before keeping your sensors in the field environment. So, these entire range of procedures you always have to follow. Currently, we are proceeding ahead with these sensors because they are already calibrated, and we have selected some manufacturer based calibration sensors. So, they are obtained with factory calibration only, and after that we have conducted some reliability tests in the laboratory environment with a waiting period of like 24 hours, 48 hours or 72 hours depending upon manufacturer specifications. And based on that, now we are moving ahead with the connections one by one. So, first of all, we have the very minor one that you have already studied about is your DHT11 sensor. I have just given a highlight of it over here to refresh your concepts, because we have already interfaced this particular sensor to measure two different parameters. You can see it comes with one 5-volt pin, there will be one ground pin and one pin for the signal. Sometime you may have this sensor in different versions, like with 4 pins, like with 3 pins. So, it completely depends upon your manufacturer, whether you have analog pins associated, whether you have digital pins associated. So, that completely depends the type of product you have selected from the market. After this, we have SDS011 sensor. As you know, and I have already discussed, this particular sensor we have utilized to measure two things that are basically your dust parameter. One is your PM10 parameter and second one we have is your PM2.5 parameter. And these two can help you to get idea about presence of dust parameters around you. So, what is basically this 2.5 over here? This basically defines your size of the particles. So, when it is less than 2.5 microns, so that will be measured in PM 2.5 category. Similarly, when the particle size in the air is less than 10 microns, that will be categorized into PM 10 category. Along with this, the sensor will basically check the density of these particles in the surrounding air, and this particular sensor works with laser measurement criteria. So, it will have a cavity inside where the airflow will be surrounded from the environment where it is deployed, and according to that airflow it will measure intensity or the level of pollutants available in that particular circulated air, and that only will provide you reading for the population of particles in that environment. It keeps on measuring based on 4 different pins that you have to connect over here. You can see although sensor has multiple pins, like you will find 7-6 different pins on the sensor, but there is no requirement to connect them all. You generally require to connect 4 important pins over here. One of them will be your ground terminal, that we already know that we have to connect it with the ground terminal on your Arduino board. Along with this, you have VCC terminal that you have to connect to the 5 volt of your Arduino board, and along with this it has a transmit and receive pin that you will connect on the transmit and receive pin of your Arduino board. Now, there is one interesting concept, because in the pin diagram of your Arduino board you might have studied that your starting point of the digital port, that is pin number 0 and 1, are generally dedicated as receive and transmit terminals respectively. But when you have multiple sensors in hand and you want to interface them together on your Arduino board, in that case chances are that you need multiple transmit and receive pins, and in order to do that you can declare different pins from the digital port to be used as transmit or receive. So, in the similar manner we will be utilizing different pins, such as we may declare like pin number 10 and pin number 11 as an alternative transmit and receive pin. Why? Because in my case study that we have over here, we have ESP8266 module as well as SDS011 module, and both of them work on transmit and receive pin. So, alternatively we can use them on different set of pins declared on the port. So, currently here you can see I have shown a very basic circuit diagram with 4 lines that you can connect on the system. Next to this we have your CCS811 sensor. So, this particular one again have 4 different lines, and this sensor basically works through SDA and SCL pins. So, along with your ground and power supply, that will be in this case 3.3 volt. So, instead of 5 volt, now you will be utilizing 3.3 volt from the Arduino board, and along with this the SDA and SCL pin. If you recall the Arduino board circuit diagram, or we can say the pin diagram, you might have studied the presence of SDA and SCL lines on the top of your digital port. From there also you can extend your connection for SDA and SCL on this sensor, or you can declare 2 pins, that is your A4 and A5 pin from the analog port to be used as SDA and SCL. So, that is an alternative option you can utilize again for the reason when you have multiple sensors that communicate through SDA and SCL project on the same setup. Next to this you have the connections for multi-gas sensor, which includes 6814 sensor, and this one, as I already told you, it can measure 8 different gases, but in our case we have utilized it to measure only 2 gases, that will be NO2 and CO. And the connectivity for this one, it has 2 separate pins. You can see here we have for CO and 1 pin we have for NO2, and these pins I have directly connected with the analog port over here. So, depending upon your declaration on the software side, you can utilize any of these ports as per your choice for the communication purpose. So, these are your 4 different sensors that I have shown you on the basis of circuit diagram first. Now, let us see one by one the interface code for these sensors. So, we will first study the individual code of every sensor, and then we are going to combine it to create your complete project code. So, I will show you one by one. Let us go to your IDE platform first of all, and here we are going to check some initial data about your DHT11 sensor. As I know you might have already practiced with this sensor, so I will just give a refreshing highlight on this. I will not go definitely in depth with this because you can refer to it with the previous videos easily. So, you can see first of all we have the libraries over here, then the specific pin number you can declare, or depending upon which pin you have connected on the hardware side, you can declare that over here. Next to this, the serial begin, you already know that you just have to interface with the serial monitor, and then in the loop part we have obtained values from the specific sensor in terms of temperature and humidity parameter. So, this is the basic sensor you already know. Next to this, we had in sequence the next sensor, that is your CCS811 sensor. So, let me open this one for you, and we can see the initial requirements for this particular sensor. Now, one more thing that you may need to know here is the library installations. Although we have given you an idea about library installation in the beginning of these course sessions, but still for just a refreshment about how you add different libraries, you just have to go to the tools section over there, and then you can go to manage libraries. And in manage libraries section, you will have a pop-up window soon over screen, and here you can type for the specific sensor that you are going to utilize. So, as the library has been refreshed now, so I can write here CCS811 sensor, and it will find that particular sensor for you. So, here you can see the list, because this particular sensor is manufactured by multiple companies. So, you can see the libraries from all those different companies over here. So, depending upon which sensor you have purchased or what is the manufacturer name of it, you can choose the same library to ensure that it is interfaced well as per the library positions. So, we can scroll down, and here you will find one sensor from SparkFun, because I have utilized it from the same company, and you can see here it says installed, since I have already installed this particular library. In your case, if you are using it from some other manufacturer such as Adafruit you have or DF Robot you have, you can see here we have the install option. So, you can simply click on this, and your library will be ready on your IDE platform just within few seconds. This is one way to get your libraries, and generally most of the sensors that are interfaceable with your Arduino platform, they have the libraries over here. But in case if you need to find them from the online platform, what you have to do, simply go to your Google platform, and here you can type for the specific sensor. For example, CCS811 library I am writing over here. For Arduino you have to find that library, and as I told you in the previous sessions, we can do it for two different platforms. One is your GitHub platform, and other we have is from official website of your Arduino. So, depending upon what type of library you have, you can just initiate a search, and then probably we can go to the official website of Arduino, and here you can see the link for the library, and you will find the zip file over here. Make sure you get the latest version that has all the updated codes as well as the sensor structures available. So, you can download it from here. Just click on the zip file download, and it will be ready on your system. You need not to unlock this zip file. There is no need to unzip this, because we can upload it in the zip form itself into your IDE platform. And if you recall that initial discussion, how you can do that, basically go to sketch option and then include library, and just click on add zip library, and it will immediately help you to upload your zip file directly on the platform. And as soon as your sensor libraries are updated on IDE platform, you can see them in the example section. So, generally As a beginner, you will have all the basic codes established in the example section, but for the customized library, you will have a section on the bottom of this example section. So, here you can see custom libraries, and here we have all the sensors that I have installed library manually, and you can see DHT11 sensor also, we have SDS011 also, CCS811 also, all of them are present over here. So, along with this, you will also get some initial examples from the manufacturer itself. So, even if you are going to do it as a beginner, you will always have some support from the libraries. At least you can understand the initial codes to build up your project, and then you can make some modifications into those codes to take them further for a specific project. So, currently we are talking about CCS811 sensor, and within which I have first installed two types of libraries. First one we have is your Spark1 CCS811, which is specifically your sensor library, and along with this we have wire library. Why we need this? Because this particular sensor communicates through I2C, and I2C requires wire library. So, here we have obtained that library first of all, and then we have utilized I2C address of this particular chip. This I2C address either you can find on the manufacturer specifications that will be provided by manufacturer on the data sheet of this particular sensor, and if it is not available, you can simply go to the wire library in your system, which is generally installed as an initial setup, or if you do not have, you know how to install it, just go to manage libraries and get your wire library from there. And this wire library comes with I2C scanner. So, you can see it here. You just have to open this particular platform and you can run it on any of your I2C sensor to get its address. So, it will immediately provide you the address of that particular chip, and you can use that at specific portion over here. Hope you will utilize this information also in your coming sensors. And then we have declared here your address that we have used earlier. After this, we are going to the setup part, where we have initialized your serial monitor, and after that some basic printing task we are doing over here, like the basic example we are running, or this is definitely optional, you can remove it or you can add anything else as per your choice. And after this, it is just going to check if the address of your I2C board is found right or not, and if there is an error, it will let you know. And next to this, we have the loop section, where first of all we are checking if the data is ready with the sensor, if the sensor port is communicating well and data is ready. So, in the same manner, it will first start reading your sensor values, and they will be printed one by one on your serial monitor. So, these sequences we have studied till now, and the same things we are doing with slight modifications depending upon your project in hand. After your CCS811 sensor, next thing we have in hand is your SDS011 sensor. So, we can go to the interface for this one, and you will see a very minor program over here again. First of all, you need to include the sensor library, and as we have already discussed, this particular sensor works through transmit and receive terminals. So, therefore, in order to communicate over transmit and receive, it requires one additional library, which is software serial, because that will be a serial communication conducted through your transmit and receive lines. Along with this, we have first declared some variables over here along with the error variable that we can utilize in between to check sensor status. Next to this, as I already told you, in our case we have two different chips that communicate through transmit and receive. So, one of them we can put on the dedicated transmit and receive pins, and other one we can put on the manually declared pins. So, here we have done manual declaration on pin number 10 and 11, and it will help you to communicate as a transmit and receive respectively through these pins of your digital port. After this, we have declared your serial communication, and then we have initial monitor settings as well as your sensor settings over 9600 baud rate. And then we go to the loop section, where we are first checking the error condition. If there is no error, then definitely it is going to print your sensor values. And as we know, it is going to provide you two things, one is your PM10 and other is your PM2.5. And the range of these parameters will depend upon the range of your sensor that I have already shown you with the specifications. So, this is your third important sensor we had, and then the last one we had is your multi-gas sensor. This particular example will show you the all 8 gases that it can measure. However, in the combined program later I will show you that we are utilizing only 2 gases out of this. So, this is just for the initial study that you can utilize the working of this particular sensor. Now, this sensor also works through wire library. So, we have included that over here, and then the gas sensor also we have included the library of this particular sensor. After this, we have initialized your serial monitor, and we have also tested the firmware versions, etc., which is definitely optional things. You need not to include it maybe in the final project, but yes, initially you can check the firmware settings or some initial settings of your sensor environment. Then we have the loop section, in which first we have declared a float C variable that we will be utilizing further to get details of all gases from the environment. First of all, you can see a small block of code over here that is to measure NH3. After that, we have another code over here that is for CO measurement. One more we have for NO2, it can also measure C3H8, and then we have C4H10, then we have CH4 and H2, and ultimately one more is your C2H50H. And interestingly, you have a task now. You have to check these chemical symbols of all the gases, and soon you will come to know that what are the representations over here, because these are 8 different gases, and you can check these codes and you will come to know different types of options available with this sensor. But currently we are utilizing only 2 of these, that will be nitrogen dioxide as well as carbon monoxide. So, this is your 4th sensor sequence that we have understood by now. And ultimately we are going to design your final set of codes based on the ESP board connection. So, before we move ahead, we need to see how your ESP board works, and you can see on screen it has different pins that you can see over here. There are some ground pins, there are transmit and receive, and then we have RST pins, there is 3 volt pin and some GPIO pins are also. You may not need to connect all of these pins. Initially, when we start working with this ESP8266 module, we require to initialize it with some AT commands. You can search more about this, or I can provide you some content about this in the e-content also. So, you can check for detailed AT commands in the e-content, that how you can interface this at initial level. With the help of those AT commands only, you can configure this particular sensor, and then you can also set its mode of communication, which will be through your Wi-Fi setup. Once you have initialized it with AT commands, then you are ready to use it with any of your chip collections. So, it can be any bigger project whose data you want to send online, and for that what connections you have to make, you can see here in the circuit diagram. One will be definitely your ground terminal, one will be your VCC terminal. Other than this, you have one transmit, one receive terminal, and along with this you need to connect the channel enable to the 3.3 volt. Along with this, there will be a GPIO pin that will be connected to the ground terminal. So, these connections you can update in your circuit diagram, and then your final set will be ready in the form of this complete circuit diagram. So, you can see here we have the Arduino board, along with which we have connected all the sensors with the help of a breadboard also, or you can have a PCB based chip that you can utilize to create your entire set of connections. The connectivity I have shown you with the pin numbers differently that we have utilized on the hardware side, and the same details we will be setting up on the software side. So, before I show you the hardware part of this particular, let us have a view on the entire set of code. That will be the detailed code for this particular hardware setup. Till now we have seen individual codes for all the sensors, and now we will see the combined code that will give you an idea that how your multiple sensors get combined to same setup. And for this you can basically utilize a sequence of events as I have shown over here. How we combine different sensors into same code? First of all, I have created a separate subblock that will be library subblock. It includes different types of libraries that I will be utilizing for setting up your sensors. So, you can see here we have DHT library, we have SDS library, software serial library, wire library, and then SparkFun library. Along with this, I have one STD library over here, which is utilized if you have to define some functions, some macros inside your program. Since I will be creating multiple subroutines over here, so I may also need this particular library over here. Next to this, first of all, we have initialized your different pins, as well as if we have to declare some pins to be used as alternative conditions. So, you can see the transmit and receive pin sequence over here, then we have initialized it with the SDS monitor, and then we have your DHT pin, and the type of DHT is DHT11 sensor over here. Depending upon what library you have used for DHT sensor, you may have to do these initializations. After this, we have your CCS811 sensor, for which we have used the default I2C address, and then we have initialized that address with respect to the sensor itself. Then we have defined different parameters in sequence, including your parameters that we are measuring from the field environment, along with some error terminologies that you can use to check variation in the sensors based on some error conditions. After this, we may have to define the Wi-Fi credentials that you can utilize to send your data to different types of environments, and then possibly you can utilize a IP address. This completely depends upon your setup that you want to utilize. So, in my case, I am sending this data to Thingspeak platform, but in your case you may have different servers or maybe different platforms where you want to send data. So, accordingly you have to update the IP address of your channel over there. And then for this Thingspeak platform, we have a specific set of channel keys, so that we have updated over here. These are basically channel write keys that you can utilize to write on the server of this Thingspeak platform. And after this, we come to the setup part, doing all the initialization, and now the setup part is ready. In this setup, we have first declared your communications with serial monitor as well as with the sensors. Then, as I told you that ESP module initially we test with the AT commands. So, a simple initialization with AT commands I have done over here. That will be just to check if Wi-Fi connections are ready or not. So, this connect Wi-Fi subroutine I have added by the end of the program, that will be recalled based on the connectivity of this particular chip. And after this, it is initialized and we are ready to begin with the wire as well as your DHT sensor. We have initialized all of them, and then CCS811 also we have initialized, and now we come to the loop part. In the loop part, I have created several sub blocks that will be getting data from different sensors. One by one we are reading all the sensors. So, you can see first of all output from your multi-gas sensor over here. We have measured NO2 and CO on only instead of all those 8 parameters. And next to this, we have another block for DHT11 sensor, So, you already know that we can create a sequence of readings over here and we can display them on the serial monitor, and of course, if you want to utilize your LCD board also, you can update that. And next to this we have your update for your temperature settings. Why we are doing this basically? Because in your CCS811 sensor you need temperature compensation, that is essential for calibration as well as for sustainable readings from the field environment. So, in order to do that temperature compensation for this particular sensor, we are first storing those temperature and humidity values in a buffer that we can further utilize for the compensation purpose. And next to this we have your SDS011 sensor, and you can see the block over here for PM 2.5 and 10 we have created over here. And then CCS811 sensor, where I have first set it up my environmental variable for the compensation purpose that we have recalled from the buffer itself, and then if the data is available accurately, we are reading that and putting that on the serial monitor. And next to this we have a tiny subroutine to check error status for CCS811 sensor. If there is some error or some wiring issue with the sensor, we will be notified about that. And after this we have added a delay of some seconds over here based on what will be the sampling time, how fast you want to send your data to the internet. Accordingly you can add a delay over here. So, that currently we have added with 5 minutes over here, or you can change it to smaller or larger sequences. And after this we have the subroutine for updating these values on the internet, and there will be another subroutine for sending your data through Wi-Fi connection. So, for this you can see here we have a sequence, that is the error sequence, you need not to worry about, and then we have the update for IP address. And here you can see it is first initializing with the IP address that we have already declared, that was for the Thingspeak channel. And after this we have another sequence that will be for sending your field variables. So, one by one you can see we have sent temperature, then we have humidity, then we have PM, both variables, and after this all the gases we have updated one by one in all the field environments up to VOC. All the 8 parameters we have sent online. And lastly we have your Wi-Fi connection over here. With this Wi-Fi connection, first I have initialized it into mode 1, that will initialize your connection for sending data on the Wi-Fi terminal, and then we have obtained the SSID and password of your particular Wi-Fi network through which we will be sending data. And once it is ready, we are able to send your data to the online platform. So, this is your software side of the story. Now, you need to see the hardware, that how it will be connected, because we have connected multiple sensors together over here. So, you will see definitely a mess of wires over here, because several sensors are jumbled up into the same project over here. And here I can show you, first of all we have your favorite Arduino board that you already know, with multiple ports and multiple chips available on the board over here. We have connected it with the USB terminal over here, and you already know this is for the interface purpose. Along with this you can see a setup of sensors over here. First of all, your favorite DHT module that you have utilized several times in the previous projects as well. So, this one basically has your 3 pins that we have connected right here with your VCC, ground, and a port with pin number 7. And there is one interesting part. Instead of using a breadboard, we have utilized a customized chip over here. This particular chip we have designed to create a common VCC and ground connection. So, this will basically provide you one side of the terminal for the VCC and other side of terminal for the ground we have utilized, so that all your sensors that are interfaced can get the common connections from here itself. Next we have this multi-gas sensor. As you can see, it has different pins over here that we have connected through these wires further, and first 2 wires we will utilizing for VCC and ground, and then other 2 wires that will be used on your analog terminal right here, because here we have the analog pins connected for the same sensor. Next to this, here we have the ESP terminal. You can see this particular chip and it is connected through 5 different wires. As I told you, we need not to connect all the pins of this particular sensor. Few are empty and others we have connected the transmit and receive respectively on the transmit and receive terminals of your Arduino board. Similarly, you have some common VCC terminals and ground terminals as we always need for the chip itself. And here you can see when the chip starts communicating, it shows a red line. Along with that, a blue LED keeps on fluctuating in between. Whenever it is sending some data to the internet, that blue LED will fluctuate in between. That will not be on continuously. And along with this, we have your CCS811 sensor. So, this one, as you know, it can measure your CO2 and VOC parameters, and we have connected it through your SDA and SCL lines over here, along with the 3.3 volt. As I told you, it will not work on 5 volt connection. So, we have utilized a 3.3 volt from here, and the ground connection we have taken from the common chip over here. So, this is another sensor. We have your SDS1, which is basically a cavity based sensor with leisure parameter measurement, and you have the range of wires connected over here. From this hole, it keeps on taking your airflow, and accordingly it will keep on measuring density of particles inside, and the readings will be available on your screen. So, this is your entire set of sensors we have interfaced on the hardware side. And now let me show you the readings that we are getting on the screen with this entire interface. So, as you know, we just have to open your serial monitor over here, and as soon as we are ready with this, I have connected it with a Wi-Fi terminal, and we can see the readings. First of all, the mode of your Wi-Fi terminal, that is your ESP8266 is decided. Then it has obtained the password and SSID, and after this you can see all the readings are ready on our screen. Based on the sampling time of the sensor data, depending upon in which field environment you have loaded it, you can see the readings over here. With a small delay, they will be updated in sequence over here. But now, as you know, you cannot put your laptop or computer in the field environment. When you are working on some real time data, you have to put your sensor system in a field environment. You need some online platform where you can send your data and you can monitor it on regular basis. For that, we have different approaches. Either you can create an application, you can create a web based system, or you can utilize some existing IoT platforms. In our case, as I told you, we have utilized Thingspeak platform. So, currently you can see it has sent field environment data. So, field 1 this value, and then we have field 2 this particular value, and one by one all the field parameters it has sent with these specific values. And the same readings will get on the online platform that we have interfaced with the specific IP address and channel keys. So, let me show you that one also. This is your Thingspeak platform. On this particular platform, you can design your own channels based on the login ID and your user ID available over here. As a free user, you can create 4 different channels on this, and if you go for subscription, you can definitely create many more. But in the 4 channels itself, you can have 8 different parameters in each channel. So, that is sufficient for your initial studies. And you can start creating your channels, such as first I have logged in here, and here you can see the list of channels. So, I can go to my channels, and here I have a list of channels that I have already created based on the field environment where I have installed this particular setup. And from there only I can open one of the terminals, that was the library terminal, and you can see a continuous sequence of readings we are getting on the screen. This is your web based interface. And you can see the last reading we have obtained is less than a minute ago, and the channel started 2 years ago, and continuously we are getting this number of entries we have obtained till now. And you can see first we have the temperature variable, then the humidity variable, then the PM variables, both of them we are updating, and then the gases, all of them are updated here one by one. So, how your environmental conditions are varying, accordingly you are getting data on your this platform. But at the same time, you would like to see this data on your mobile phone as well, because you may need that interface on the go instead of being dependent on some web based platform. So, for that, the good thing is that this Thingspeak platform can be further interfaced with several freely available apps. So, even if you do not want to create your app, you can use some existing applications, enter your channel IDs over there and log in with your account, and you can see the data over there. For example, I can show you one output over here. This is with your the same Nature CSC data I am getting over here. This is a library terminal data we are getting continuously, the same readings that I have shown you on the screen right now. So, this information you can see continuously on your phone, and even if you are out of your town or out of your house, you can find these readings easily. And this thing is available on ThingsView app currently, but there are 10-15 different types of applications that you can utilize freely, and you can see this data on regular basis easily. So, this is your entire set of information you are getting from the field environment, and next to this you can do the analysis easily. Once your data is available, you are ready to analyze it, and for that there is a easy task. You can export this data by going to the data import export section, and as soon as you go here, you can find the CSV file. So, as you have to export it right now, you can choose the specific time zone in which you are working, where you have installed your these sensors right now. So, for example, I am picking up New Delhi over here. So, this will take up the same time zone, and we can download this data right here, and you can see it is basically a Excel file that we are getting downloaded on your system, and this CSV file will contain all your field measurement parameters that you can utilize further to understand conditions of this particular data, and it will help you to create your data analysis. That will definitely be another level of study that you can do, possibly with the help of some Python based coding or MATLAB based coding. So, currently I am showing you data from the same hardware network that we have obtained on this Excel file right here. You can see there are unlimited readings. I can scroll through like lakhs of readings we have obtained from this particular hardware, and we can do variety of analysis, and we can forecast something, or maybe the conditions of gases we can forecast based on this. So, this is all about your case study on indoor air pollution management, and I hope you have obtained some relevant details about how we can interface multiple sensors, how can combine multiple sensor codes together into one code, as well as what are the options for sending your data to the Wi-Fi terminal. So, this interesting case study can create a base for you to design many other projects depending upon your area of work. So, thank you very much students for having patience to go through this entire session, and I hope you can practice more based on these sensor environments. I have shared all the details with you that you may need as a beginner. Thank you so much for this video, and we will meet again in other session.